So hello everyone, we just started MCQ series. In last chapter we were done with units and measurement, which is first chapter of class 11. Today we'll go with the scalar and vectors. So let's start. First question is, which of the following is a vector quantity? Vector is simply those who have direction plus magnitude. So mass, temperature and speed, all three are scalar. So acceleration would be the right answer because it's also have a direction. Second, which of the following is scalar now? So scalar, we know acceleration is vector, force is vector, velocity is vector, but work only have the magnitude but no direction. In contact to scalar quantity must have, so we know when we talk about a scalar, it's only have magnitude because direction is not present. So when we compare both of them, we only find direction as a something extra in a vector, and that also is very much important because that give us idea these are the different quantities. Which of the following group of quantities represent the vectors? So vector, we know here we saw that mass is what? Mass is a scalar quantity, so this means mass is scalar. We need to find the vector. Secondly, here acceleration, what we saw, acceleration is a vector quantity, so let's keep this aside. Then here again we have mass, this means it's again cancel. So last one is velocity. Velocity is vector. Electric field momentum is also vector, but here electric flux, which is scalar, so this means D is the right option. Then the following physical quantities are vector. Which are vectors? We need to identify that. So force and displacement are called as vectors. Vectors are physical quantities which are completely specified by both magnitude and direction, because magnitude only means it's a scalar quantity, only direction is not present in any of these, so this means magnitude and direction is important. Then we have scalar quantities have only magnitude, as I mentioned. A unit of vector, like unit is simply when they have only one or unities. How we need to find? We denote all by a which is equal to the question value we have and divide by its own magnitude, which we represent by this. So this formula you see is called as unit vector, and I think it's a. It's kind of below, but still a is the right option. A vector in a space has dash components, so it has a three components. How we know that? This is simply, this is x region, this is y region, this is z, so three components in a space. When a vector is multiplied by a negative number, its direction is reversed. This means the direction become opposite on its reverse, whatever direction it was. Then we have a vector which can be changed by parallel to itself. This means we are going to parallel body. If this is the shape, again it's going in the same direction. That's vector is called as parallel vector. A vector in any given direction whose magnitude is unity is called. So unity, wherever unity means one. So wherever you see unity, this means we are talking about the unit vector. The position vector of point P is a vector that represents its position with respect to the origin of coordinate system. Then we have negative vector have a direction that of the original vector which is perpendicular. When it's perpendicular, that means one is positive, second is negative. The sum and difference of two vectors are equal in magnitude. The angle between the vectors is, so sum of different two vectors, if this is vector, this is vector, and when we talk about the magnitude, so the angle between them is 90. So this means B is the right option. And then let's change color. The dot product of I and j is 0. Dot product, which means scalar quantity, and we know scalar products which are obtained by when two vectors are multiplied. Sorry, it's not wrong, it's right, by the way. Two vectors when they are multiplied and the answer is scalar, that's called as a scalar product. Then if dot product of two vectors which are not perpendicular to each other is 0, then either of the vectors obtained by adding two or more vectors called as null vector. Is simply when you get the answer 0, or we just simply say, so null vector is simply whose magnitude which is equal to 0, it's called as null vector, which is also obtained when two vectors, if we have two vectors which is having equal magnitude but opposite in direction. When they are opposite in direction, they are also called as null vector. So I hope it will be clear, and right answer here is the, because they're saying dot product of two vector which are not perpendicular, and yes, it's also very important that they should not be perpendicular to each other, which is 0. So So I hope it will be clear. Then the vector obtains by adding two or more vectors. This means if we have this one component, if this is the component, this if we add a plus b, we'll get this, and this is called as resultant. So this means C is the right option. Scalar product of two vectors obeys commutative plus associative law. This simply means a plus b or b plus a is called as commutative, or we simply say associative, simply a plus b multiplied by c, or a b plus c. This means both are like multiplying, so this is associative law. If dot product of two non-zero vectors a and b is zero, the cross product will be magnitude of. And if dot product of two non-zero vector, non-zero, this means they are not zero, their a is also equal to something, b is also equal to something. The cross product will be, so it will be simply ab, because we don't have, they are two non-zero digit, and a b are simply zero. Dot product is simply finding their scalar quantities. K into I is, we know we have three components, so x is called as I, j is called as y, like y is called as j, k is called as z, or I mean z is called as k, I, j, k. So here we know k into I, this means we are finding angle between them, so it's equal to, of course, not minus j and not minus k. K, I don't know how they've written b, but still there might be some trick. Otherwise this question is simply, we know k into I is x, k is z, so if you multiply we'll get b according to this PDF. If a into h is 0 and a into h is 0, then either a, this means one of them is a null vector. That's why if we multiply we are getting 0. Null vector simply means having 0, having magnitude 0. So if you multiply any digit with 0, this means we'll get answer. So this means either a or h, one is null vector, that's why we are getting answer into 0. And then magnitude of a into b is equal to c, so that's called as area of parallelogram, which is also one kind of method we need to study. If two vector, I hope you would have studied, if two vector line xy plane, the cross product lies between, parallel to the plane, not in the same plane, of course. If xy plane, the cross product which lies along to the parallel, so this means it would be the right option. Then we have, which of the following quantities are called as vectors? We know mass, wherever you see mass, it means a scalar quantity. Wherever you see temperature, it's a scalar quantity. Wherever you see weight, it's a scalar quantity. So this means if we talk about force and displacement, they both are the vector. So I hope it will be clear. The quantities which can be added, subtracted, multiplied, this means the quantity which obeys the mass rule is called as, that's scalar. Okay, choose the vector. Vector is simply, as I mentioned, mass means it's wrong, velocity and speed, velocity is wrong, velocity again wrong. This means force and acceleration are called as vector. Quantity which show magnitude only are called, so we know scalar only represent magnitude, however vector represent magnitude plus direction. So here scalar, a quantity which show both magnitude, as I mentioned here, so the vector is the right option. Which are the following as scalar quantities? So force, we know it's vector. Velocity, we know it's vector. Volume and weight, we know volume and vector, these are vector. And speed and mass, speed is scalar, of course we know. So speed and mass both are scalar, that's why this is the right option. Choose the scalar. Scalar is simply electrostatic potential, is called a scalar. However, these three are vector quantities. Length of the tail of the arrow represent the, so we know if this is the tail, this is ending point, this is tail, and this is going to represent what? This is going to represent magnitude, so remember that. A vector A is given in any direction whose magnitude is unity, so this means wherever you see unity, this means we're talking about one or unit vector. So I hope it will be clear. Then we have, when a vector is divided by its own magnitude, when it's going to be divided by its own magnitude, then we also getting unit vectors. Remember that vector A has the same magnitude as, but B has opposite in direction. So this means if this is the body, one is going in this direction, second is opposite. So this means the vector is going to be called as negative vector because they are changing or they're opposite in the direction. Sum of two vectors equal in magnitude but opposite in direction, which is also providing 0 because the energy you apply on this side is simply they're taking it back, so this means it's going to be 0 or negative. And to all vectors we add the represented line by right hand rule is very important. In order to add vectors we have head to tail. Head on, this is simply head of one to the tail of others, so here would be head, so head of tail, this means this is going to be the right option, head of one to the tail of others. In order to add vector we join by this, a vector which can be displaced parallel to itself. When they're parallel to itself, parallel vector simply, this means they have same angles but different magnitudes. That's called as um, free vector, or which question we were doing, but that's called as parallel vector, I mean to say, which is a parallel to itself. But here they're asking which is parallel to itself and applied to any one point. So free vector is simply that vector addition is associative plus commutative but not distributive, it's in the quantity. A vector whose tail lies at the origin of coordinates, whose head lies at the position of p in space called as, that's called as a position vector. They're again highlighting the position. And then we have, if the magnitude and direction two vectors same, these two vectors are, this means they are equal because magnitude and direction they both are the same. Division of a vector into its vertical component, that's called the resolution of vector. Okay, then we have the components of position vector are formed as coordinates. The components, if this is the component x y z, this means we know these components are called as coordinates because we have x-axis, x coordinates, y coordinates, z coordinates. Then we have a vector lying along x-axis, this means the y component is equal to 0. The resulted vector of two vectors will be 0 if the magnitude of both vectors is same and angle between, this means angle is 180. Here the direction is 900, which is wrong. The magnitude of vector is 0. No, magnitude is supposed to be, and the magnitude of both vectors should be same, or an angle between them should be 180. This means the right option. Here their direction is 150. Magnitude of both vectors is different. No, we need same magnitude. The magnitude of resultant of two vector acting at a right angle is dash, it's more than that. The angle between the rectangular component of a vector is always equal to 90. Rectangular components mean making right angle, this means one x-axis, y-axis, they have 90 degree. Then if vector A lies in the xy plane and make an angle theta, the side of y-axis, its component y component is called as ay. When we find ay, which is called as cos theta, when we phi a axis, then it is equal to sin theta. So this is all about the vector. We have done so many MCQs. I hope it will be very much clear. Thank you for watching. Bye bye.